The world you see is not what currently exists. At this very moment, you are looking into the past. It's interesting to know that some of the bright stars you see in the night sky are images from billions of years ago, from a time when Earth did not yet exist, from a time when even galaxies were just beginning to form. But how is it possible for us to see the past of the universe? Does it really mean we are somehow traveling in time? And is it possible that one day we could actually see the moment of the Big Bang itself? These are all questions that might have occurred to you, and in this video we will talk about them. Without keeping you waiting, I want to dive into this amazing mystery that connects science and imagination. Why is it that when we look at distant galaxies we are seeing the past? The reason is because of the speed of light. In fact, even though light is the fastest thing in the universe, it still has limitations. The speed of light is about 300,000 kilometers per second. This means that light can circle the Earth 7 times in 1 second. Now, the interesting and strange truth is that when an object is very far from us, the light that reaches us from it is from a very long time ago, because light needs a lot of time to cover this vast distance. In other words, the farther an object is in space, the longer it takes for its light to reach us. So when we see it now, we are actually seeing an image of its past. The reason is that space and time are interconnected in the universe. We use light years to measure distances, the distance that light travels in 1 year. About 9.5 trillion kilometers. Let me clarify this with a simple example for you. If you look at someone in the next room, you are actually seeing an image from a few nanoseconds ago, because that's how long it takes for the light to reach our eyes. Or when we look at the sun, its light is from approximately 8 minutes and 20 seconds ago. After the sun, the closest star to us is Alpha Centauri, which can be seen with the naked eye, and its image is from 4 years ago. So the light we see from the sun takes about 8 minutes to reach us, and the light from Alpha Centauri takes 4 Earth years in total to reach us. The star is visible to the human eye, but the James Webb Telescope can look back up to 13 billion years and see the first stars and galaxies that formed after the Big Bang. But if you look at the Andromeda Galaxy, which is one of the few galaxies visible to the naked eye on a dark night without light pollution, you are actually seeing an image from 2.5 million years ago. In fact, on a dark night without light pollution, this galaxy appears as a faint, blurry spot in the constellation of Andromeda. On the other hand, in the constellation of Ursa Major or the Big Dipper, there are spiral galaxies and stars whose light has been traveling through space since the time dinosaurs roamed the Earth and has now reached us. Well, let's move on to an amazing example. A galaxy named Z8GND5296 is one of the most distant galaxies ever observed. The light from this galaxy has been traveling for 13.1 billion years to reach us. This means we see it as it was in the early universe, about 700 million years after the Big Bang. Of course, today even more distant galaxies have been discovered, such as the galaxy GNZ11. And galaxies discovered by the James Webb Telescope, some of which date back to 300 to 400 million years after the Big Bang. Now that we've mentioned the James Webb Telescope, let's tackle a challenging question. How do telescopes act like time machines? Space telescopes like Hubble and James Webb capture images of the early eras of the universe by observing extremely distant galaxies. For instance, as mentioned, when the James Webb Telescope observes a galaxy like GNZ11, it is actually showing us an image from 13.4 billion years ago. Now, what does this mean? It means that the image was captured at a time when the Earth, the Sun, and even the Milky Way galaxy did not exist. So we are looking into the past, at very distant times when the first galaxies were just beginning to form. But one of the most famous images taken by the Hubble Space Telescope is the Hubble Deep Field. This image you are seeing was taken in 1995 with the aim of studying distant galaxies. Interestingly, to enhance the details, 342 separate exposures were taken over 10 days from a very small section of the sky. After these images were put together, they realized that in this small and dark section of the sky, there are thousands of galaxies, some of which are more than 12 billion light-years away from us. This image is very important because it shows that in every point of the sky, even places that seem empty, there are thousands of galaxies. Additionally, scientists were able to gain a better understanding of the density and distribution of galaxies in the universe. Let's move on to the James Webb. Since the James Webb Space Telescope, which operates in the infrared range, has come into play, it can see even further back than this. In fact, unlike Hubble, James Webb can see more details of galactic structures, because infrared allows us to reach very distant lights through cosmic dust. A prominent example of the James Webb Telescope's performance is the image released in 2022 of the galaxy cluster SMACS 0723. As we can see, this image is an excellent example of James Webb's new capabilities in discovering and examining parts of the universe that have remained unknown until now, allowing us to take a look at one of the farthest points in the cosmos. Additionally, indeed, some of the background galaxies visible in this image are transmitting light from a much earlier era of the universe, even just a few million years after the Big Bang. But can we actually see the moment of the Big Bang itself? The answer to this question is no. Because the moment of the Big Bang and even the early periods following it, the universe was extremely dense and hot, and light was unable to pass through this thick and foggy matter. In fact, it was only when the universe became transparent and the recombination or electron decoupling era began, about 380,000 years after the Big Bang, that light could move freely. We observe this through the cosmic microwave background radiation, or CMB, which we discussed in detail in another video on the channel. Therefore, what we see is an image from the period after the Big Bang, not the exact moment of the Big Bang itself. In other words, the cosmic microwave background radiation, or CMB, is the oldest thing we can observe. This radiation proves the occurrence of the Big Bang, but it only shows the universe at 380,000 years old, not before that. Well, up to this point, we have understood that telescopes can look into the past, but some scientists have interesting theories regarding this. For example, some of them are examining whether it is possible for an extraterrestrial civilization to be watching Earth's past right now. Or if a very distant civilization is 65 million light-years away from us and has a very powerful telescope, could it see the exact moment when dinosaurs were living on Earth? Of course, there is still no definitive evidence for these topics, but the universe is full of wonders and mysteries. Who knows? Maybe one day we will find the answers to these mysteries. What do you think? Do you believe that one day we might be able to uncover more secrets of the unknowns of the universe? Or even think that other civilizations might currently be observing Earth's past? Be sure to write your opinion in the comments, and I'm sure we can start a challenging discussion together. If you haven't yet appreciated the video or turned on the channel notifications, be sure to definitely do so and support us by sharing this video with your friends. Now, if we want to summarize everything we've said, it must be noted that telescopes really act like time machines and help us see into the past of our universe, because light takes time to reach us. Additionally, galaxies like ZGND 5296 show an image from 13 billion years ago, which is the early era of the universe. Also, by examining the light from distant galaxies, we can understand how the first stars and galaxies formed. The Big Bang cannot be directly observed, but the cosmic microwave background radiation is the oldest light that proves the occurrence of the Big Bang, and many mysteries of the universe remain unsolved. Additionally, it's possible that other civilizations are currently observing Earth's past.